Hi friends, in the series of Java interview questions and answers, last time we discussed how we can create the singleton class, what are the advantages of doing lazy loading of the singleton class, and why we should not do directly instantiate the singleton class. So basically, if we are doing the lazy loading, we can call the get instance method at the time of requirement, and it will not be every time in the memory. And it will create the instance if it is required, and if it will return if it is already there. So that was the advantage. Also, we saw in the last that there is a pattern to break the singleton. There is a reflections which can break the singleton pattern. So let's see today how we can break the singleton with the help of reflection, and let's learn about the reflection. Hope you will enjoy this content. So let's start it. So I've created this reflection demo class, and so first let me define what we will be covering here. So first thing is why use of reflections. Use of reflections. So first use is we can change during runtime. This I will give the top priority. We can change during the runtime properties of the class. Second, I will give the priorities debugging. Debugging is good with the help of reflection. Third, I will go with the test cases, JUnit test cases. So these are most often used of reflections, and in the Spring Boot server also, or any other application server. We mainly use the reflections to create, the injections are based on the reflections. So let's begin and see how we can change during the runtime. So let me create one method first, private one property, number variable, private string, and demo name. Okay, so let me this one, yeah. Let's generate the getter and setter quickly. Now let's try to see, let's try to print through the reflection what are the properties of this private. So public method is the public, so this is the main method. And to create the object through the reflection or get the class, we we have to see the fully qualified name of this reflection demo class. So let me show you. Class reflection demo equals to class dot for name, and I have to give the fully qualified name. So what I should give first, the package name. So I will come to this fully qualified name. What is the class path? How we can give the fully qualified name? I will come that on the later point. So reflections dot fully qualified name will be reflection demo. So basically it's saying to surround it with the try catch. So let me surround it with the try catch. So it will throw the class. It can throw the class not found exception. So we must be aware in the Java that there is a class object for every class, and how that class object is created, we will be discussing that, and what all metadata it will hold. So class object basically will contain the metadata, number of methods, number of constructors, all that private methods, member variables, all that information is contained in the class object. So let me see. So if we will see here in the reflection demo, so basically there will be get declared methods. So we can see list of features which are available. Basically declare methods, so it will return the list of methods. Then there will be reflection demo, reflection demo dot get declared fields, so it will return the fields, list of fields, and reflection demo dot get constructors. There will be get constructors also. So see, there are get constructors, get declared constructors, so we will come to that also. So these basically are the things which we can remember or even can memorize, that simply with the class object we can get the details for variables, for the methods, for the constructors. So simple to remember this one. So for this, currently let's comment this one, and let me comment this one as well. So let me use this one. So I will write it here, and so it will basically return the fields. You can directly write the fields. So the package is javalang.reflect package, so it will automatically suggest this one. So we have to use this one. So fields, and it will give the array of that one. So yeah, if you will see here, they have imported the javalang.reflect.field automatically. And let me iterate over this one. So for fields, and let me print out it, system.out.println. So field is so let me run it. So we are seeing how reflection is working basically. Now I will run it, and you have to bear with me again if any error comes. Or so see, demo name, so it printing the private, we can see here it is printing the private member, which is demo name. So see, it can show the demo name is a one member variable, and the reflection demo class, and it's we can see these properties also. Similarly, if we will print the methods here, so let me uncomment the method one here, and let me move this to down. So similarly, there will be for method. So you can note these things easily. Yes, methods, fields, and constructors, and there will be many more things, but these basics should be, I think, on the tips. So for methods, you simply write it methods. Don't need to look anywhere. Simply write method, and inside it should be list of method. So now it should automatically give it. You can press Alt Enter for the shortcut. So yeah, javalang.reflect. So this is the package. Now for the methods also, we can simply iterate over it. So let me quickly save the time. Methods, method, and then method. Here I will iterate over methods, and yeah. So I can write here is method. So it will list all the public method. Also it can list the private method as well. So let's see. So it's easy to memorize, I think. So see, it has printed the method name also. Set demo name, get demo name, and then there is one main method. Okay, now let's come to this fully qualified name. So this fully qualified name is based on the package. So I can create one more same class reflection demo in the other package. So we can create the same class in the other package. So they will be distinguished based on the package name. So that's how this fully qualified name helps to distinguish the class name. Then comes the second point. Second point is, let me go to, and I will show you like how this reflection demo is coming. So for that I think the notepad will be the best thing. So I can create this one. So let me create one more package here. And let me create in the top level package. I will be removing that. So test package, and the test package, let me create a new Java class, and let me say it's ABC or test package creation package. So test package, and what I will be doing, yeah, just test package is sufficient I think. So I can change the package here. So that what I was showing you. So I can give the package name as PC. Let's give package name as PC. Let it give the error, and it's not the issue. So just let me print one method here, public, so we can confirm that it's running. So I will come to how the fully qualified name works. Sorry for that. So yeah, now just let it print something. Print something. Okay. Now what we will do is we will go copy this class path, copy the complete path, copy path, absolute path, and we'll switch it here. So let me go to this cd, paste the path. So I'll switch to this path. Now we'll see it. Let how we can. So in this PC we can even create this PC package. So in our IntelliJ it will follow that convention that it should have test package only. So if it will remove the error if we will do test. But let's create a PC package and see how this qualified name works. So now what I will do is I will do javac, and what is the class name, and I have to give the directory and where I have to compile this and generate that package structure. So this is the command to generate the package. So now if you will see here, so if you see PC is the one package it is created. So now to run this we should not go inside this one, PC dot test package. So print something, it printed. So that's where package is working, even though ID is saying it's wrong package, but we created this package. So see, if you see the qualified name is pc.test package, it's automatically generated. So that's the way qualified name is working. It's we should note that in the path, in the path variable, if I will give echo $java home, which I have set. Okay, so let me do it full screen. So this is the path variable. So this path variable is basically for the compiler to analyze where the JDK is there. Now we will come to the class path. So we have understood path, we have understood the fully qualified name. Now let's go to the class path. So let me open the diagram. So class path is the path where it will look up for the .class file. So it will follow the delegation algorithm. It will first search. So interview questions, so in the interview questions they also ask how class loading work. So we have to give this answer. First it will do the delegation algorithm. It will look in the application class loader, then the extension class loader, and then the bootstrap class loader, and then it will come back. So means application class loader will pass it to the extension class loader, extension class loader will pass it to the bootstrap class loader. If bootstrap it is not present, then it will come back to extension class loader is not present, then it will come back to application class loader. And default path of application class loader is current path, means this dot. So yeah, current path is the default path. So this is the current path. So this is the class path for our this test package.java. So when we run this, it will load directly from here. So now we will come to the concept of how it will create the class object. Let me open the document back. So yeah, so this one, yeah. So here if you will see, so in the initialization, it will load the class object. So let me read it. So see, class loader loads the following things in the method area: fully qualified. So this is the metadata: fully qualified name of the class, qualified name of the immediate parent class, method information, variable information, constructor information, and the constant pool information. So this all metadata information will be there in the class object. The .class file above information, so it will load it into the method area. So it will load it into this method area, this class object. So now let's go back and continue. So hope it will give you more clarity that how class object get loaded. And remember, there will be only one class object, irrespective of the number of instances you create. Class object for each class, there will be one class object. Okay, one class object for irrespective of number of instances you create. Class object will be one. So now let's go back to this class object. So we came here, and I will remove this. Yeah. So we have understood the reflections here, how we are getting this class objects, and what the metadata it will be holding. And now let's go back, and now what I will do is, let me try to break that private singleton pattern. So for singleton pattern, the prerequisite is you should be going through the video of the singleton pattern, or you should have the understanding how we can create a singleton class. So let me create this private reflection demo, a singleton private constructor. So now we have created the private constructor here. Now what we will try to do is, we will try to break this analogy, and we will try to create the instance of this. So let me comment it out, this one, and yeah, so we can leave it also. So now we will come to constructor. So for that we have to get the constructors list. Again, java.lang.reflect, then you will get the list of constructors. So again, list of constructors. So what is the class object here? Reflection demo is a class object, and reflection demo dot get. So get declared constructor I will write. So declared constructor will have the hold of private constructor. If I will do the get constructors, it will not cover the private constructor. So that is the difference. So again, I think it's easy to remember, and there is nothing to forget. Quickly iterate over this. For constructors, and let me, yeah, so we have to create an instance of that one. So let's create the instance. So what is our class name? Reflection demo. So this is the, and let me reflection demo 1. It will be this confusing name. So test demo, let me refactor it to test demo, and let me initialize it to null. And then what I will do is, if yeah, so constructor dot new constructor, first we have to do the property set accessible equals to true. Now even though the constructor is private, it will be accessible because we are setting the property set accessible is true. Now what we can do is we can create the instance directly from dot new instance and new instance, and yeah, so it's throwing error because of the it is throwing the exception, so let's surround it with the try catch. And what we will do is we will typecast into the test demo of our reflection demo object. So yeah, now we have created the object. Now let me see. So see, now if I will do reflection demo, let me come out of the loop. Yeah, I am out of the loop, and let me break this as well. So I will break it if test demo is not equals to null. Break it. So we should not continue further. Let's break it, and then let me come out of the and set some string name or demo name here. So reflection demo dot set reflection demo, sorry, test demo was the name of the object. So test demo dot set demo name, test breaking creating the constructor even if it is private, creating the object even it is the private constructor. So this way the JUnit power mock it also unit the private constructor. So and let's print it system what is the test demo dot get demo name. So it should print this supposed to. So let's try to run it. So it helps a lot in the debugging skill. So see, we have created it successfully in the instance, and it's printing also, creating the object even it is a private constructor. So super, it's working. And this is how we can create the instance of the we can break the singleton pattern by reflections. So when we will be learning enums, we will come to that topic why we should use enums. So Java internally does not provide any hack for the enums even through the reflections. So we should use enums for the singleton object. So we will go through that one also. So hope you like this content, and it will be easy to remember. We should know get in methods, get names, get fields, get methods, and get declared methods, get declared constructors. So that's all, and we can change the property. We can easily see set accessible equals to true, same for the private fields also. And it is useful even in the runtime. Sometimes we want to dynamically change anything for the class like this one. That time also it will be useful. So okay friends, let's meet in the next video, and hope you enjoyed the content. Bye bye, good to see you.